And now let's move on to the heart of the head. This part, where the focusing lens is located, the collimator, well, these lenses that condition the laser, the light, so that it has the right shape for cutting. Here we also have a servo motor, which is what moves the focusing lens to perform piercings or different stages, that is, to position it. That fine part of the laser, exactly in the position we want. So let's get started. The servo motor, the collimator, and the focusing lens are the main parts at the heart of the head. First, here we have the servo motor, which is basically what moves the focusing lens. This connector is constantly moving the focal lens. Here, we have some linear guides to allow for free movement. And here inside, there's the focusing lens is what shapes the laser into a cone and creates that fine point on the surface of the material. And here we also have the collimator, which is before the focusing lens, at the top. The collimator. Basically, what it does first is condition the light so that it travels in a sort of cylinder. So, there's a module that, in fact, isn't just a single lens. It's actually two lenses. Here we can see them, and of course, someone might ask, Diego, how are you opening the headpiece? And supposedly, this is supposed to be a completely sterile area. In fact, we're opening this up in a non-sterile environment because this headpiece is damaged. Some dust got inside due to the operator's carelessness. And look what happens. These spots appear because when the laser reacts with the dust, it starts to generate heat and leaves these marks that block the light. Eventually, when one of these marks appears, the headpiece just stops working altogether. So, one of the main precautions is to never let this kind of dust or any debris or sparks get into the headpiece. These would be the main parts. Honestly, I really like it. We're going to take it apart a little more, but for now we have it open enough. It's exposed enough for me to explain it to you. Here in the collimator, I have some springs, and over here I have the two screws. All the heads come with this calibration system. That way, I can adjust the position of the collimator until it is completely perpendicular to the focusing lens. If it's not completely perpendicular, then the laser point will end up way too far to the right or left. So, this collimator, with the help of the springs and these two screws, lets me move it along the X and Y axis and have the laser fully calibrated so it comes out right at the tip. This is the one that basically adjusts it so the beam comes out through the center of the little nozzle. And this focus adjustment, on the other hand, is what raises and lowers this cone. That's all for now. Let's keep taking it apart a little more. Now we have all the pieces of the optical system out, and with that, we can clearly understand how the head works. Let's start from the top. Here we have the QVH connector, which is where the source, the laser beam, enters and where the path begins. Next, we have a first protective lens that prevents any dust or sparks from getting into the heart of the head. Next, we have the collimator, which is this set of two lenses that direct or modify the light beam so that it travels down as a cylinder and stays centered throughout its entire path. That's why we have a centering system with screws that have a very fine thread, so we can be precise. Then we have the focusing lens. This lens is the one that shapes the laser into a cone and focuses it onto a point so intense that it can actually cut through steel. Let's say this is the one that does the magic, and it's also the only movable lens. I mean, it's also a set of two lenses, but this is the only one that moves when the head is operating. Here we can see a gauge that goes from +10 to -10, and what moves it is a servo motor that's located at the back. This is the servo motor that, depending on the command sent from the computer and depending on the material, will adjust the position, moving the focus and, as a result, the position of this finest point. We have a lower protective lens, which is number 2. Generally, it's the last barrier to protect this part, which is the heart of the laser. And finally, the lower lens is the one that's constantly in contact with sparks or debris, because it's the first barrier for everything that enters through the nozzle. This is the path of the light. As we can see here, we have these 3 protective lenses with a collimator and focusing lens, and this servo motor system that moves additionally. There are other relatively simple things, for example, the limit switches, which are optical systems that notify the servo motor "Thank you" when it has reached the maximum upper position and the maximum lower position, and also encoder systems that allow it to maintain feedback almost in real time to know if the position of the servo motor of the focusing lens is correct. This is basically the entire structure of the head. As you can see, it's an almost completely optical system because we're working with light. The weight, in fact, is only because of the issue of precision, and because they heat up, you have to cool it, but really, the ones doing all the work are this set of lenses. That's why we say that laser technology isn't such a complicated technology, but it is a very, very sensitive one. In fact, 90% of the problems we sometimes find in the industry are due to some kind of dust or debris getting into one of these systems. And then the light gets blocked, and with that, the head is completely damaged. And now let's move on to the most important part, conclusions and recommendations. First of all, the handling or operation part must be done by experts, therefore, the recommendation is that you should never open, if you have a head or a machine, or if you're going to buy a laser machine. Never open any of these parts. In fact, that's what these videos are for, so you can see inside what it has inside without needing to open up your equipment. The moment you open it, you're exposing it to a non-sterile environment. Sometimes, in any scenario, in any environment, there is dust. There are tiny bits of lint that we don't notice, but when they get into the head, they interfere with the laser's path and end up damaging the head. That's the first recommendation. Now let's move on to point number 2, the operating principle. What you see here is basically the principle behind 99% of fiber laser heads. The thing is, all fiber laser heads have a collimator, a focusing lens, and protective lenses. There are different variations. For example, some heads have temperature control on the lenses in case they start getting too hot, to give a warning. Others have more internal cooling circuits in these aluminum parts, and well, it also depends on the power. So the lenses are generally larger, the parts tend to be bigger because they need more cooling. That's why it's very noticeable when you come across a larger head. Usually, it tends to be higher power, but all of them follow the same operating principle. Let's say that's the basic idea. It's like with cars, we have a wide variety of cars, but the vast majority work on the same basic principle. Basically, it's an optical system that modifies the laser inside with some components to achieve this goal. And number 3, let's talk a little about quality. A lot of times we think that if a head is bigger, it must be more expensive or of better quality. But the reality is that's not the case. The laser machine needs a smaller head to be able to accelerate faster and reach higher speeds. So, having a very heavy head requires bigger servo motors and stronger moments of inertia. So ideally, you want the heads to be as small and as light as possible, and that will make the process more efficient. Another extremely important point is the quality of the lenses. While it's true that there are many brands on the market, there's Right Tools, there's also Precitech, and FS Cut as well. In this case, this head is specially manufactured for FORZA Laser, so I highly doubt you'll find it on the market. And the head is not only defined by its components, but also by the quality of the lenses. These lenses are American, and the lifespan will depend on the internal components, which, well, is very hard to tell at first glance. That's why the recommendation is to trust laser specialists like us, since we truly live and breathe this technology day and night, always looking for improvements, searching for the best tools, the best head, the best source, so we can achieve those perfect laser cuts. And that's all for today. We have another video of a different head being taken apart. Feel free to subscribe and leave your comments, questions, or ideas for other videos you'd like us to make. See you soon!